Hello, everyone. Um, in the previous class, we studied about the topic for the previous class was on electrical components, and we looked at various kinds of electrical components, including things like switches. We also saw that we have resistors, transistors, and other kinds of components. And we saw that a bulb uh, utilizes the um okay, we saw that our conclusion was that an electronic component is whatever device that is going to sit within a circuit, like this battery, like this bulb over here, and basically utilize the flow of electrons to do something. In the case of a bulb, is to produce light, and in the case of something like a resistor, is to vary that voltage difference, and in the case of a capacitor, which we also saw yesterday, um, was to store an electrical charge temporarily. So with that, but today, but okay, the big question from yesterday's class is how can we utilize these electrical components to uh, build a computer, or basically how a computers utilize electricity to do the same. So, but for today, we are going to um, study what are signals. We're going to start from signals. And according to Wikipedia, a signal is a function or a physical quantity that conveys information about a phenomenon, typically over time or space. Examples of signals are voltages, currents, and light. Also, temperature is a signal. But in order to understand signals in their most basic forms, we can look at various kinds of signals that uh, were used, or rather are still being used to convey any kind of information. Like the first signal you can look at is something like this. This is a traffic light, and it signals by producing these lights. Like we can see that green. If you're driving and you see a green light, you know that it it says go. You can go. The way is clear for you. But if you see amber, it says that you're supposed to get ready to move. And if you see stop, that's basically need to stop your vehicle and wait. This is a very nice example of a signal. A signal is basically anything that's going to convey information, and anyone that sees this information will understand what that means. In this case, the information is being conveyed, in this case, by the colors of these lights. So the light is a medium that's conveying information, and that light has color that essentially we have all agreed that red will mean this, amber will mean this, and green will mean something else. So we can look at another form of a signal. This we can see that smoke. In the past, usually, I guess smoke was usually used to convey that there is some danger or something is not right. So they will lit a fire, and probably people in wherever they're staying, they could come and probably help or something. And also, other than smoke, we also have sound like blowing of a horn to symbolize probably people going to war, or I'm not sure what, but basically it would convey something. So a signal is simply information traveling from one place to another. And also it can also be a gesture, like uh, someone will wave to say goodbye or to say hello. But since we all know that this is what this waving means, essentially we agree on that, and it's essentially called a signal. Okay, it doesn't really matter what is being sent, so long as people on the receiving end understand the meaning. So you can find that in one tribe or one community, people probably, let's say, they use uh, fire or smoke to symbolize danger. You can find others that use the same smoke to maybe symbolize something like there is a celebration, so people can come to gather around, or there is something that requires people to gather around for maybe a meeting or something. So essentially, the medium of signaling does not matter, so long as the people on the receiving end interpret it as something. And random noise. Random noise is not part of a signal. For random noise is something that essentially, like, an example of random noise that I could give is probably if you notice that on the old television we will have them showing grainy noise, and also on radios, also the analog radios, they are still, if you're not tuned to the right frequency, you usually hear noise. You usually hear noise. It's called the cosmic microwave background, and that's noise because us, whoever who are receiving, we don't actually know how to interpret that. So that's noise. Okay. So there are several types of signals. We have analog signals, like I said, the use of a microphone. A speaker also is an analog uses an analog kind of signal. We also have the old televisions and the old kinds of radios as well. Other than that, we also have digital kind of signals. These are signals that are used on computers, microcontrollers, your smartphones, and basically this is what we are trying to understand how it works, since it's the most it's what is used to develop a computer as we know it today. So okay, in this case, we have established that we can represent a signal. So the bigger question here is, can we use the electricity that we have, like take advantage of something like this circuit over here and over here, and the electron flow through the circuit to represent anything, since we have established that a signal, the movement of electrons to produce electricity, that's an electric signal. And since it's a signal, it means that we can find a way to package it in some way that we are able to understand what that means. So do you think we can do that? And the answer would be yes, but we would like to look at something called it's called a telegraph before we continue. So this is going to help us understand if we can actually do that. So, okay, what is a telegraph? A telegraph is a communication device used to transmit text or coded messages over long distance using electric signals. And basically this is how it's a really old device, but the way it works is really interesting. So people in the past didn't have a way to like send communication far away unless you probably have to move to like other places to send that information. So, and with the rise of electrons, people are so innovative enough that the person who came up with this is someone called Samuel Morse, who built this device which is able to utilize the flow of electrons, which is basically electricity, to build a device that is able to, as we said, from signaling, is able, as long as you encode something, it doesn't matter what you're encoding or rather representing, as long as if you send it and the person on the receiving end is able to understand, basically that's information. So it doesn't really matter the medium. So, but the telegraph used to encode this kind of data. It was designed in such a way that it's an electronic device that is able to represent some characters and send it over. As we are told here, it's a device used to transmit text or coded messages over long distances. And this was very revolutionary, like it brought great change since it was able to transmit data over really long distances, like we're talking continents to continent. So it was really helpful. And the thing was just encoding those patterns of information into the electrical channel that was already being used. Okay, so essentially I'll probably explain how this works. As you can see, it's a simple circuit. On this side, we have an operator. This is a person whose main job is to whose main job is to enter characters into this machine. First, before we see how it works, we can see that people started by like they came up with this structure. This is like a representation, like it's an agreement or rather a standard that people used to say, they agreed upon. So the device, the telegraph, it sends information by creating these dots and dashes. And through these dots and dashes and poses, you can create, there's already an agreed upon pattern for that, and that's able to be decoded into sentences. So if someone wants to send something like an A, they click once, that's a dot, then they hold for a bit, for like, the dot was like less than a second, half a second, then for like 1.5 of a second, that's a dash. So by doing that a lot of time and pausing in between these things, someone will just send these signals. They're basically like electric fluctuations uh, within these within these circuits to whatever destination. And whoever is in that other side, what they are able to do is just get these fluctuations of uh, electric signals and find a way to undo them, or rather just using the same table, listen, or rather see what's being created, the dots and the dashes, and reconstruct it. So yeah, that's the basic thing. So let's see how it works. So an operator is someone like this, who in this case they will listen to those beep sounds and be able uh, to understand. So before that, we'll see how it works. So the work of the operator is to look at that, this table that we have seen of the agreed upon patterns that everyone agrees on. And if they want to click an A, to send an A, they have to click once for a second and then hold for like 1.5 seconds. And that signal will be sent over the wire to this receiving end. That's probably 1,000 kilometers away or very far, or wherever you want to send that information. And basically, what it will do is use electromagnetism, is a coil, to uh, electrically magnetize this coil. And if this metal is a magnet, becomes a temporary magnet, at that moment it pulls down this lever, and this let me call it a hammer, and it hits over here for that exactly that moment that they send, that duration that they send. And another listener on the other side will be able to listen at the same hammer knocks, and or rather, this in this case, this is a design that uses a tape. By writing, this one is supposed to write over here on this tape, dash dot dot dash space and everything. And that the other person will take that, then find this table and be able to map whatever the dash and the dots mean to whatever the message is. So essentially, that's the full uh, uh, that's the full thing of a signal in this case. And yeah, there is another design of this telegraph that uses sound. So basically, an operator on this other side, or whoever is here on the receiving end, is able to listen and recognize the information that's being sent, or rather the characters, to the information that is trying the sender is trying to convey. Okay, and that is usually possible by, again, something that is standard and is agreed upon. In this case, that was Morse code for the telegraph. And yeah, that's basically it. And here we can see how it will usually work. So we could listen at this in the here. Yep, as you can see on the video, the operator is able to click in any characters and to represent anything they want. And as long as the person on the other side is able to listen on to that, then we essentially have communication, and we're using this representation of any characters or anything basically to our own advantage to do anything we want. So a computer works in a similar way as the telegraph to represent patterns carrying information. We understand information that we understand, but the difference is that computers, at least the modern computers, they use binary representation. So it's not really different, as long as we have something that's agreed upon by everyone, that we can use these signals and they represent this, and whoever is on the receiving side can take these signals that they receive and use the same standard that we all agreed upon, which in this case would be the binary representation of maybe characters. In this case, we are able to decode, or rather, yeah, let me just use decode that information, and usually that's a full that's we're essentially using we're essentially utilizing a computer in a way that it will help us. But now the good thing with computers use binary, and the good thing with binary is that it only uses two states, and two states are also best used by electricity. So we can have electricity present or not present, and if electricity is present or the circuit is on, we are able to represent that as one binary one. And if no electricity is present in the circuit, that's a zero. But we're not talking about binary in this lesson, but we are going to in the future lessons understand how computers usually are built from binary representation. We're also going to look at how computers utilize something we called a branch of mathematics that we called Boolean algebra. That's Boolean logic to perform computation on this information. Also think of a computer as we said on the telegraph, we had an operator usually sitting around and manually looking at the sheet that is required and clicking the hammer on this side his job was to click this. Where is this? His job was to tap these to create the data that was to be transmitted over the wire, and this will automatically decode it. This is a sounder. The difference between this over here is that this writes the dots and dash, but this one produces sound that operators can listen to and be able to understand what the information is. And so essentially what I'm saying is essentially this was acting as a switch. So as we progress, we're going to understand how important a switch is, since a switch is what will mostly be used to create this binary by allowing current to flow, or really blocking the circuit so that current does not flow within the circuit, to also represent information. And we are also going to learn about how, instead of using just manual switch like this kind of switch in this circuit, that's probably manual, this one, we are going to study how we're going to study the conductors materials, semiconductors, transistors, which are essentially switches, but they're switches controlled by electric signals. We're also going to look at that in future lessons, and also, most importantly, Boolean logic, which will help us construct the computers as we know it from ground up. So yeah, I think that's enough lesson for today. And yeah, I'll leave you with this. So see you in the next class.